Hello everybody. We are starting Unit 12, which is graphing trig functions. So we're going to start with just kind of an introduction to trig functions and see what the graphs actually look like and see the components of them as well. So if you look at the do now, it said convert the following degree measures into radians. So first we have 0. So if we were to convert 0 degrees into radians, what we would have to do is we'd have to multiply it by pi over 180. Okay, when we multiply this by pi over 180, if you multiply 0 by anything, you just get 0. So this is 0 radians. Next one we're going to look at is 90 degrees. So again, to convert into radians, we have to multiply this by pi over 180. When we do that, we get 90 pi over 180. We want to simplify that 90 over 180. So if you can't simplify it, that's okay. You can use your calculator. 90 divided by 180. And we want it in fraction, so math frac. It becomes 1 over 2. So this is the same thing as saying pi over 2 radians. Next we have 180. To convert, multiply by pi over 180. We get 180 pi over 180. The 180s cross out and we're just left with pi radians. Okay, then we have 270. Same process. Multiply by pi over 180. Then we have 270 pi over 180. And when you simplify that, you actually get 3 pi over 2. So lastly, we have 360. I'm going to see where I can squeeze this on this paper over here. Let's just do it right here. It's 360. So multiply by pi over 180. Have the equal sign down there. So we'll get 360 pi over 180. And that gives us 2 pi radians. Okay, so now let's look at the second part of the do now. The second part says fill out the following table. Now, this table seems kind of familiar, but we've never seen it with radians yet. We usually see this with degree measures, but we just converted all of our major degree measures into radians. And look, 90 degrees is the same thing as pi over 2. Pi over 2 is over here, so this is the same thing as saying 90 degrees. Then we have 180 degrees. 180 degrees is the same as pi radians. So this is the same as 180. And the same applies for the rest. So for 270 and for 360. So we can kind of use this to guide us to fill out this chart. So when we filled it out, it was sine of 0 is 0, cosine of 0 is 1. And then it followed the pattern 0, 1, 0, negative 1, 0. Cosine is 1, 0, negative 1, 0, 1. Same exact pattern, just cosine starts at 0. Sine starts at 0, cosine starts at 1. So, a periodic function. A periodic function is a trigonometric function which repeats. That is super important. So sine and cosine graphs, they're going to continue to repeat the same pattern over and over and over again. One complete repetition is called a cycle. Now these are called sinusoidal. I don't even know how to pronounce that word, but that's another way to refer to sine and cosine graphs. So this is what the sine graph looks like. Again, this pattern repeats over and over again. That's why you'll see this side over here looks the same as this side over here. Now, in order to graph sine and cosine functions, you need to be comfortable with what they look like. So the main part of the sine graph is it starts at 0 with no changes made to it. Then it goes up to 1, it goes down to -1, and then it goes back to the center. So notice the start point and the end point are on the same line. That is sine. Now looking at cosine, it looks very, very similar. However, the difference is cosine starts at 1, so it starts above, then it goes down, and then it goes back up. So you're going to need to know that sine, the graph looks like this, and cosine, the graph looks like that. Alright, so we're going to be focusing on vocabulary today because we are going to be using this vocabulary throughout the unit. First is midline. Midline is the horizontal distance that passes exactly in the middle between the maximum and minimum points. So here's kind of an equation to find the midline. So you take the minimum, you add it to the maximum, and then you divide by 2. But if you're given a graph, you can kind of just look at it. So if we look at this first graph here, the graph looks like that. The middle of the graph is this line here. So that is our midline. The midline is an equation. So the equation, since it's a horizontal line, would be y equals 2. And then the same can apply for the other graph. Here is our graph. The exact middle of the graph is right over here. And the middle of that point is y equals 0. So let's try to find the equation of the midline here. So the equation of the midline is you look at the middle of your graph, or you take your maximum point, which is your highest, and your minimum point, which is your lowest. You add them up. So I'm going to do max plus min, and then you divide by 2 to find the middle. So the maximum point was 3, and then to that we're adding a -5, and then we're dividing by 2. So alpha y equals 3 plus -5 divided by 2, and it gives us -1. So that tells us that our midline is at y equals -1. Now if we look at it on the graph, that is this line right here. And if we were to count the spaces from this midline to the maximum point, it would be 1, 2, 3, 4. If we want to count this from the midline to the minimum point, it would be 1, 2, 3, 4. So that's why it is the middle of our graph. Next is amplitude. Amplitude is the vertical distance between the midline and one of the extremum points. Extremum, that means min or max. It could be either or. So if we look at this, in order to find the amplitude, we first have to find the midline. So let's start by finding the midline. To find the midline, you do the min plus max divided by 2. In this case, our minimum is -5. Our maximum is 1. we have to divide that by 2. -5 plus 1 is a -4. -4 divided by 2 is a -2. So our midline is at y equals -2. So to find the amplitude, we have to find the distance between the midline and either a maximum or minimum point. So here is our maximum point. So from the midline to that point, it is 1, 2, it is 1, 2, 3 spaces up. So that tells us that our amplitude is 3. Next definition is a vertical shift. A vertical shift is a translation of the graph up or down a certain number of units. So what you can do to find this is you just take a point on the original and compare it to a point on the new one. How many do I have to go up or down, and how many spaces? So it says determine the vertical shift here. So again, first thing I want to do, the blue is our original, the dotted line is our new graph. So we take a point from the original and compare it to a point on the dotted. Okay, so 2 things we want to answer. Does it go up or down? And how many units? So to get from the blue to the red, we have to go down 1. So we have to go down, and we go down 1 unit. So the vertical shift is 1 unit down. Next is period. So a period is the horizontal length of 1 complete cycle. That's why it's super important that you can identify the difference between sine and cosine. Remember, a sine graph, it starts at the midline, it goes up, and then ends at the midline. It kind of looks like an S a little bit. And cosine looks like this. So you're pretty much finding the distance that it takes to get through one of these shapes. So if we look here, it said determine the period of the following graph. The best way to do this is kind of outline one cycle of the graph. So this is a cosine because it does not start at the midline, it starts above. So a cosine graph, it starts above, it goes down, and then it ends at the top. So what I outlined in red right here, that is one complete cycle. So I want to see how long it took to complete that cycle. So I'm going to go down and I'm going to look at the value on the x-axis. So that tells us that the period is 6 pi, because that's how long it took to complete one cycle. Frequency. The frequency is the number of cycles the graph completes in a given interval. So again, you have to know what a cycle looks like for sine and cosine in order to find the frequency. So it says determine the frequency from 0 to pi. So pi is right over here. So that's our ending point. Now, if we look at this graph, we'll notice that it starts at 0. So it starts at the midline. That tells us that this is a sine graph. So I'm going to see how many full cycles this graph goes through from 0 to pi. So I'm going to outline one cycle. So here, that was one rotation of sine. And now we're going to outline another. So this was the second rotation, and then we've hit our endpoint. So that tells us that the frequency from 0 to pi is 2. All right, so let's practice graphing. Let's see what this graph looks like. So this is kind of like the chart we filled out in the beginning, but it starts with cosine this time instead of sine. So be careful of that. So let's just fill out our information. Now, we have radians here. We're used to degrees. So we can change that. So we can make this 90, 180, 270, and 360. Now it goes in the negative direction. We haven't seen that yet. But with the pattern, nothing is going to change. So negative 180, negative 270, negative 360. So let's first look at the cosine. Cosine of 0 is 1. Then we follow our pattern. 0, negative 1, 0, 1. And the pattern still goes in the opposite direction. 0, negative 1, 0, 1. Now for sine, the sine of 0 is 0. And let's follow our pattern. 1, 0, negative 1, 0. Same in the opposite direction. Negative 1, 0, 1, 0. So notice that these values and these values for sine and cosine are exactly the same because it cycles through the same exact pattern. So let's first graph cosine. So cosine of negative 2 pi was 1. Let's first figure out where 1 is going to be here. I'm going to make 1 2 spaces up. So negative 2 pi, 1. Negative 3 over 2 is 0. And negative 1, 0, 1, 0, negative 1, 0, 1. This is going to be a very repetitive pattern, and we're going to use this repetitive pattern throughout this whole unit. So let's connect. Notice I'm using curved lines. I'm not connecting it like this. You need that smooth curve at the bottom of the sine and the cosine graphs. So now let's plot sine. So sine starts at 0. Then we have 1, 0, negative 1, 0, 1, 0, negative 1, 0. And again, we're going to connect it with smooth lines. So this was the standard sine and cosine graph. What we will be doing later on in this unit is we are going to be changing some things about it. So we'll be changing the amplitude, the midline, the frequency, and so on. But that's what the graphs look like. Okay, so to get credit for today's lesson, you have to complete this check for understanding problem on a separate sheet of paper, and you must attach a picture of your work and your solutions onto the assignment on Google Classroom. Have a great day, everybody.